Hello, we're going to be taking a look at Chapter 5, problem number 27. And in this particular problem, we have an object that is moving in a horizontal circle. So we're going to take a top view of that object's motion. And here is the object. We're told that the circle has a radius of 2.9 meters. Now, we're also told that the object's acceleration is 1.05 meters per second squared in a direction that makes an angle of 32 degrees to its direction of motion. Let's take that apart. Its direction of motion, of course, is going to be tangent here. We don't know its speed, so we'll call that v. And we're told that the acceleration is at an angle that is 32 degrees from that direction. So there's my acceleration right there. Let's take that acceleration and put it over here so that we can see it a little bit more clearly. 1.05 meters per second squared. And it's going to make an angle of 32 degrees with the velocity. And now they ask two questions. First of all, they ask you to determine its speed at this moment, or its speed right now. And in B, they ask you to determine the speed 2.00 seconds from now. The key word for this problem is components. We are going to use the object itself as the reference frame, and we're going to think of components that are parallel and perpendicular to the direction of motion. In other words, we're going to take A and we're going to split it up into a centripetal component, or a component that is perpendicular to the direction of motion, and we're going to break it up into a component that is tangential, or parallel to the direction of motion. And those two components are fairly easy to compute because they make a nice little right triangle. Here is a perpendicular and here is a parallel. And I think that you can see that the centripetal or perpendicular component is opposite to the 32-degree angle, and so therefore is the sine component. And the tangential component, or the parallel component, is adjacent to the 32-degree angle, and therefore it is the cosine component. When we get actual numbers for these two components, by plugging in sine theta, cosine theta, we get 0.556 meters, that's 556, meters per second squared for the centripetal component, and 0.890 meters per second squared for the parallel component. This process of splitting the acceleration up into two components, which are parallel and perpendicular to the direction of motion, is just basic preparatory work for analyzing the motion here. Having done that preparatory work, we're now ready to answer parts A and B. In part A, we have the value of the centripetal acceleration, and we know that centripetal acceleration is always equal to the v squared over r. So we have 0.556 meters per second squared equals v squared divided by the given radius of the circle, which is 2.90 meters. And that gives us a current speed of 1.27 meters per second. Remember that it is the perpendicular or centripetal component of acceleration that causes the object to move in a circle. It changes the direction of the object. And that is why I knew that I could find the speed by setting the centripetal acceleration equal to v squared over r. The 0.556 meters per second squared is the acceleration required to force the object to go in a circle. By contrast, the parallel component of the acceleration changes the speed of the object. And that is going to allow us to find the speed 2 seconds from now with the simple equation v equals v0 plus a times t. We have the current speed, which is 1.27 meters per second. We have the parallel or tangential acceleration of 0.890 meters per second squared, and we're going to accelerate for 2 seconds. So that the velocity 2 seconds from now is going to be 3.05 meters per second. So to sum it all up, we began by doing some preparatory work. We took the acceleration and split it up into 2 components, the tangential component and the centripetal component, and we found those using simple trig. Then we let each of those components do its particular function. The centripetal component moves the object in a circle and therefore must be equal to v squared over r, and the tangential component changes